Hi class, let's get started with diseases of the respiratory system. This presentation is going to comprise three main parts. We're first going to talk about some of the structures and defenses, then we'll talk about normal biota, and then the majority of this chapter is focused on actual diseases of our respiratory system. So to get started, let's talk about the upper and lower respiratory tracts. Structures of the upper respiratory tract include mouth, nose, nasal cavity, sinuses, throat, pharynx, throat/pharynx, pharynx if you're in your anatomy class, throat in most other settings, and epiglottis. And then the structures of the lower respiratory tract are everything from the trachea down. So the trachea, bronchi, bronchioles, alveoli, these guys are going to be within the lungs, and the primary bronchi are outside of the lungs, but the secondary and tertiary bronchi will be within our lungs. So here's the same thing that we just talked about. We have the lower respiratory tract and then the upper respiratory tract. Some defenses that we have in our respiratory tract include a mucociliary escalator within our trachea. This mucociliary escalator is going to function to capture bacteria that have been inhaled. The bacterium are going to be moved superiorly or up out of the trachea. Moving the bacteria, we have many ciliated cells that are constantly beating their cilia, moving the bacteria and moving the mucus that has trapped the bacteria. We also are going to have some microvilli sections. These sections of microvilli within the trachea do not function to move mucus or move bacteria, but instead they function to sample the mucus and sample the pathogens and potential antigens that are within that mucus. So this is going to be some lymphoid tissue right here where we have those microvilli. We also have some viscerae or nasal hair traps. These are going to be located by our nostrils, also known as the external nares. As I mentioned before, we had our mucociliary escalator with the cilia propelling particles trapped in mucus out of our respiratory tract. And that mucus lines most of our respiratory tract. And it's just a wonderful sticky trap that catches many of those microorganisms. We're also going to have some second and third lines of defense as well. We have the complement system that's been activated or with complement proteins available. We'll have our antimicrobial peptides, chemocytokines, macrophages, and secretory immunoglobulin A, all present within the mucous membrane of our respiratory tracts. If we look at the normal biota of our respiratory tract, we can find that some of this normal biota, when it's out of balance, or if we're working with an immunocompromised patient, can cause a disease state. Some of these normal biota include Streptococcus pyogenes, Haemophilus influenzae, Streptococcus pneumoniae, and Neisseria meningitis. Depending on the composition of these normal biota and the other biota that are present, the microbiome can differ from a patient to patient, particularly if they have a different respiratory disease. So if they have chronic obstructive pulmonary disease, COPD, asthma, and or cystic fibrosis. It's also worth emphasizing that yeast, Candida albicans, is also capable of colonizing the mucosal surfaces. Anybody who is going to smoke is going to have a different biota compared to someone who does not smoke, because you're exposing the mucus and the respiratory tract to different chemicals, different limiting factors, and different essential nutrients. This normal biota that's present in our respiratory tract is a part of the normal microbial antagonism that we have. This normal biota helps to outcompete the pathogens that may potentially make us sick or cause a disease state. So these are going to make it so that there's less room, so to speak, for the pathogenic bacterium to grow. If we look at Lactobacillus sakei in particular, this bacterium suppresses Corynebacterium tuberculostericum within our sinuses. In other words, the presence of this commensalistic bacterium is going to suppress that pathogenic bacterium from growing. So if we look at the defenses of our respiratory tract, they include lots of hairs, mucus, cilia, and first and second lines of defense. So phagocytotically active cells, complement proteins, antimicrobial peptides, and immunoglobulin A. With our lower respiratory tract, we don't have quite as many lines of defense. We have less mucus. We don't have those cilia, but we do have alveolar macrophages. And we'll still have the secretory immunoglobulin A. Within the upper respiratory tract, there's a wide variety of normal biota that will typically vary from individual to individual based off their disease state and their lifestyle choices. And within the lower respiratory tract, it's kind of unclear. It's difficult to retrieve samples from the lower respiratory tract and culture them and ensure that there was no contamination from somewhere else. If you have any questions about this material, please feel free to post them on the discussion board or get back to me with an email. Happy studies!